In this example, we'll solve another system using the elimination method. We notice that both of our equations are in standard form, but that we don't have a pair of opposite pairs in our coefficients. We have opposite signs with this positive 6 and the negative 2, but we don't have the same number. There are two different methods that we can use in order to create an opposite pair. The first method would be to just simply multiply the first equation by 3 and the second equation by 2, switch one of the signs, and then we could have an opposite pair of the x and eliminate x. Or you can instead multiply the bottom equation by a positive 3. By multiplying by 3, we'd get negative 6y, which gives us our opposite pair with the positive 6y. This way we only have to multiply one equation. So when we multiply, we get 2x plus 6y equals 18, and 9x minus 6y equals to 48. Since we now have an opposite pair, we can add our two equations together. So 2 plus 9 gives us 11x. Positive 6 plus negative 6 gives you a positive 0y. And 18 plus 48 is 66. The 0y goes away, so we're left with 11x equal to 66. Finally, we divide by 11 so that we see that x is equal to 6. Just like in the other equation, other example, we'll plug 6 in, and it doesn't matter which x we plug it into. I'm just going to plug it into the top one. So we're going to have 2 times 6 plus 6y equals to 18. So 2 times 6 is 12, plus 6y equals to 18, minus the 12, 6y is equal to 6, divide by 6, so y is equal to 1. Giving us our final answer of 6, 1. Again, because we have one intersection point, we know that this graph would look like two lines intersecting at the point 6, 1. Now let's take a look at this example. We see that we don't have an opposite pair, but we are in standard form. So you try and solve this equation this system of equations by using elimination.